Hello and welcome to Learn Data. It's great to have you back on this channel. I'm Nilesh, and in this video we'll continue to learn about time in Pandas. In this video we'll look at pd.date underscore range and see how this works to get us a range of dates, different dates within a given range. So let's get into Jupyter Notebook and start coding. Here I've already imported two libraries, NumPy and Pandas, and these are the versions that I'm using in this notebook. So let's first look at creating a simple date range using start and end dates. So I'm going to create a variable x and then use pd.date underscore range and here for start let's use date 2020-07-01. Remember that this has to be year, month and day. And then we have 000000 for hour, minute and second. And then we have the second one, end. And for this again I'm going to use 2020-07-01. And then for time, hour minutes would be 0, but seconds I'm going to use just 1 second. And for frequency then the increment would be based on seconds, so 1 second increment. And in the output we then see that we have three dates in the output. The first one is 0 seconds. We just have two dates, so 0 second and then 1 second. So because the range is here, let me change that to 2. So okay, now we have three dates. We have 0 seconds and 1 second and 2 seconds. So both the start and the end dates are included in the output. And if we look at the type of this, so if you look at type of x, it's an index. So by default, when we are working with time data in Pandas, it is treated as an index, and therefore it's when we create a date range, it creates a date index. Now apart from seconds, let's look at a couple of more ways in which we can change the frequencies of when we are creating these date ranges. So x is equal to pd.date underscore range, and here let's say our start date is the same 2020-07 let's say 110, and the end date is 2020-07 let's say 13th. And then for frequency we have 1 day, okay, with a small d. And when we look at x, here now we see that we get an output which has 4 dates, 1 through 10 to 13, and inclusive of the first start and the end date. In middle we have 11 and 12. So that's one way to get date range with a fixed frequency. And here if we specify 2 days, let's see what happens. We get 2 dates only because that's the only dates that fit within those start and end dates that we have specified. The 14 would be greater than the end date of 13 that we have specified, so it's excluded from the output. Now let's look at a frequency of month. So I'm gonna copy this again, copy, paste, and here let's go ahead and change these to, let's say, 10th, so it's October and 1 month. So in the output now we have 3 dates, which is July, August and September. So in this case the last date is not included. If we change this to 10, still no. If we change this to 30, okay, so the last date is not included because it doesn't fit. So if we change this to 1 now, and if we change this to 31st, now we get the 4 dates, which includes the first start and the end dates in the output. In addition to the month, we can also use year. So for year, let's go ahead and change the year of this. So let's put 23, and if we change the frequency to, let's say, 1 year, and run this, we have 2020, 2021, and 2022. So that's how we can change either seconds, year, day, month, year, or any denomination of time we can change to get a specified date range within a given start and end dates. Now there is additional functionality here that we can use, which is normalize. What normalize does is it zeroes down, I think, the hours of the start and the end dates. If we have a date, let's say pd underscore date underscore range, and here if we specify start is equal to 2020-07-01, and here if we specify 23:59:59, so that's the last second of the day, and then end is equal to, let's use 2020-07-02, and then 01:01:01. Now if we specify frequency is equal to 1 second and run this, so let's see. So when we run this, we see that the first and the last dates, timestamps, have the same hour, minute, and seconds. However, that can be changed. So if we now specify normalize is equal to true, then those are zeroed out. So as you can see, the first and last dates, the start and the end dates in the output for that date range have now become 0. So that's how we can use normalize. So mistake there. Moving on, we can also go ahead and name the series that the date range that we create. So to do that, so let's say name, and for that we can type x is equal to pd dot date underscore range, start is equal to, this time we'll just use the date and not type the hours. End date is, let's say, 2020-10-12, and name we can give this, let's say, growth timeline, and look at the x. So as you can see, the final output now has the date time index date range that we got. It does have a name associated with it. So those are the ways in which we can create different types of date ranges. Now you're probably wondering, is there a way in which we can either include or exclude the start and end dates in the output? And yes, we can. So if we use the closed, so we again type x is equal to, I'm going to copy this entire thing. Okay, now here we can use a parameter called closed, and if we specify, there are different values we can specify, that is none, left, or right. So if we specify none and run this, both of them are included. If we specify left, in that case only the left one is included, the right one is not included, as you see here. And if you specify right, then the right one is included and the left one is not included. So that's a way in which we can control if the start and end dates could be included in the output. Now apart from this, so far we have specified both start and end dates, but there is a way either we can use start or end we don't have to specify both. So let's say x is equal to pd dot date underscore range, and here if we specify start is equal to 2020 07 10, and here if we specify periods, the code is missing 10. Okay, and here if we specify periods is equal to 3, so we get 3 dates in the output, and specify x. So as you can see, what we did was we specified the start date, and then based on that, with a day frequency, we have 2 additional dates automatically created. So I'm guessing if we specify the units here, so if you specify unit is equal, or frequency is equal to, let's say, 1 month, then we get 0708, so July, August and September. So that's how we can use start. And instead of start, if had we specified end date, then the digits that we get for the month in this case are subtractors, they are lower. So 07 being the highest, we get 06, 05 and 04. Now so far we have looked at getting the date ranges which have a fixed frequency of either a second, month, day or year. So the difference between any 2 consecutive dates is fixed. What if we want to create random dates between 2 given date ranges? Now that can be done, and I'm going to show one example which does not use the pd.date underscore range, but just so that you have this information on how to create random dates between 2 date ranges. We'll go through this code. So let's specify a start date as 2020-01-01, and then we have the end date which is 2020-03-10. Now if we want 10 dates between these ranges, so we specify 10. Now the first step we need to do is convert the string to a timestamp. So timestamp, and we are going to convert them in values. So if you remember from previous videos, pd.timestamp, and if you specify start here, this will give us the nanoseconds. So this will give us the timestamp, and then if you add value to it, you get the nanoseconds out. So I'm gonna use those. So value, and then copy this. The same thing for the end date that we have. So end value, and this would be end. So moving on, now what we can do is use our familiar np.random integer, and here we can specify the start val and the end val for the starting and the, so between these 2 ranges we need to find n random numbers. So that's what we are doing here. So these are the nanoseconds that we get, and now after we have these nanoseconds, we can easily convert them into dates. So to do that, let's create a variable random underscore dates, and then I will use list comprehension. If you remember, the way it works is we use the for loop. So for I in x, so we have this array up above, and here what we are going to do is pd.to_date time, and the I, that is going to be the nanosecond that we get, we are going to divide that to bring it to a day, and then we'll use the day frequency. So let's create I divided by 10 raised to power 9. So we are bringing that to seconds, and then we divide that by 16 to 60 to bring it to hours and days, and then we divide it by 24. So that will get us the value for days, number of days, and then number of days since the epoch, and then we have unit is equal to capital D, and after that we'll use the so what if we run just this part, so we are missing, okay, if we run just this and specify random dates, the output we get this format where we have this time. Now if we do not need the our time part of that, what we can do is use strf time, and here we can specify the format we need the output in. So we need capital Y because that's we need all the 4 digits of the year, and let's say we need the month as well, and we need the day as well. So once we run this, we get the random dates from the 2 date ranges that we had specified earlier. So that was it for this video. I hope you all learned how to use the functions for creating date ranges, and how to create date range of a fixed frequency such as seconds, minutes, days, year and month, and also finally how to create random dates between 2 date ranges. In next video we'll look at another function in Pandas which we can use to manipulate time data. Until then, please like, share and click the bell icon below to subscribe. I hope to see you all in the next video. Thank you.